This is SpaceTime, Series 28, Episode 102, for broadcast on the 25th of August 2025. Coming up on SpaceTime, planet Earth dodges 2 asteroid near misses within days of each other, a new moon discovered orbiting around the planet Uranus, and dancing dwarf galaxies may help predict the Milky Way's ultimate fate. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Planet Earth has just dodged 2 asteroid near misses within days of each other, both swooping past the Earth lower than the orbits of many satellites. Asteroid 2025 PF2 sped past the Earth at an altitude of just 22,000 kilometres, travelling at around 13 kilometres per second. Estimated to be somewhere between 2 and 6 metres in size, the space rock was flying in the constellation Aquila as it passed. Then there's asteroid 2025 PU1. It missed the Earth by just 29,000 kilometres, travelling at around 10 kilometres per second. It's estimated to have been somewhere between 2 and 3 metres in diameter and is currently in the direction of the constellation Pegasus. The frightening thing about 2025 PU1 is that it was only observed 4 hours after it made its closest approach. It belongs to the Apollo class of near-Earth asteroids and will make its next close approach to the Earth on April 3, 2036. It was the 10th closest asteroid flyby of Earth in just 12 months, the 85th known flyby of the planet within 1 lunar distance since the start of the year, and the 3rd so far this month. This is SpaceTime. Still to come, a new moon discovered orbiting the planet Uranus. And dancing dwarf galaxies could help predict the ultimate fate of our own Milky Way. All that and more still to come on SpaceTime. Astronomers have discovered another moon orbiting around the ice giant planet Uranus. The new observations were made using NASA's Webb Space Telescope. The previously unknown moon brings the total number of satellites orbiting Uranus to 26. The object was detected in a series of 10 40-minute-long exposure images captured by Webb's near-infrared camera. One of the study's authors, Maryam Al-Mutamid from the Southwest Research Institute in Boulder, Colorado, says it's a small but significant discovery, which is something that even NASA's Voyager 2 spacecraft didn't see during its flyby of Uranus 40 years ago. The newly discovered moon's estimated to be around 10 kilometres in diameter. That's assuming it has a similar reflectivity or albedo to Uranus's other small satellites. It was its tiny size which likely rendered it invisible to Voyager 2 and earlier telescope observations. No other planet has as many small inner moons as Uranus, and their complex interrelationships with the planet's rings hint at a chaotic history that blurs the boundary between what a ring system is and what's really a constellation of moons. Also, this new moon discovery is a lot smaller and fainter than the smallest of the previously known inner moons, making it likely that even more complexity remains to be discovered in the system. The new moon is the 14th member of the intricate constellation of small moons orbiting inwards of the largest moons, Miranda, Ariel, Umberal, Titania and Oberon, all of which were named after characters from Shakespeare and Alexander Pope. It's located about 56,000 kilometres from the centre of Uranus, and it's orbiting the ice giant's equatorial plane between the orbits of Ophelia, which is just outside the planet's main ring system, and Bianca. The authors believe its nearly circular orbit suggests that it may have formed near its current location. As for a name for the newly found moon, well, that'll wait until one's approved by the International Astronomical Union, the leading authority in assigning official names and designations to astronomical objects. The discovery continues to build upon a legacy of missions like Voyager 2, which flew past Uranus back in January 1986, giving humanity its first close-up look at this mysterious world. Now, nearly 4 decades later, the Webb Space Telescope is pushing that frontier even further. This is SpaceTime. Still to come, a new study trying to determine the ultimate fate of our Milky Way galaxy. And later in the science report, the first almost 100% effective prevention drug for HIV/AIDS. All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, Insta360, the trailblazers in 360 and action cameras, pushing the boundaries of what's possible for creators everywhere. Last week, Insta360 dropped their latest game changer, the Go Ultra, a pocket-sized camera that's redefining how you capture life's adventures. Imagine it, a camera no bigger than an Oreo, weighing just 53 grams, yet packed with the power to shoot buttery-smooth 4K video at 60 frames per second. It's small enough to slip into your pocket, but delivers professional-grade footage that'll make your vlogs, travel diaries or family moments look absolutely stunning. What makes the Go Ultra stand out? Its magnetic mounting system lets you get creative with your shots in seconds. You can clip it to your shirt or hat for hands-free POV footage while you're running, biking or chasing your kids around the park. Or you can stick it on any magnetic surface, like bike frames, gym equipment, or even a street sign for those unique angles that no other camera can match. The standalone camera is the IPX8, waterproof up to 33 feet. So it's ready to roll whether you're surfing, swimming, or caught in the rain. And the Go Ultra's upgraded sensor and AI chip ensures your shots are always crisp and vibrant day or night. And here's the best part. For the first 30 SpaceTime listeners who purchase the Insta360 Go Ultra at store.insta360.com, you'll score a free Sticky Tabs accessory to mount your camera on anything from backpacks to winter jackets. Just use the promo code SpaceTime at the checkout. That's store.insta360.com, promo code SpaceTime. Just go to our links page for full details and descriptions. So don't miss out on this titan of a camera that's ready to capture your world like never before. That's the Insta360 Go Ultra. And now it's back to our show. A new study is trying to determine the ultimate fate of our Milky Way galaxy as it hurtles towards a merger with our big galactic neighbour M31 Andromeda. As the two galaxies come closer together, the gravitational tidal forces interacting between them will cause both to undergo massive changes. Now, a new study reported in the Journal of the Monthly Notices of the Royal Astronomical Society suggests that the cosmic dance of smaller satellite galaxies orbiting around the two giants will also play a significant role in that ultimate cosmic collision. One of the study's authors, Sarah Sweet from the University of Queensland, says the Milky Way will merge with Andromeda and with their respective smaller dwarf galaxies in the next 2.5 to 7 billion years. And while there's been a lot of research into what's happening in our local galactic group, astronomers really don't know how typical that will be. So to better understand how representative such a galactic collision will be, Sweet and colleagues studied NGC 5713 and NGC 5719, which are two very similar spiral galaxies which are about 3 billion years ahead of where the Milky Way and Andromeda now are in their merging. The authors are showing that these galaxies are combining as if they were dancing with closely located dwarf satellites rotating around them. It may provide our clearest look yet at how structures like the Milky Way satellite galaxy system forms, and how over the next few billion years it'll evolve. Understanding our galaxy's likely future helps astronomers refine models of galactic evolution, models of dark matter, and models of the cosmic structure of the universe. Sweet says we're all part of a much larger cosmic story, one that unfolds over billions of years, involving dances of galaxies and the shaping of the universe itself. She says by comparing our local galaxy group with other systems like it, astronomers can determine whether the Milky Way and Andromeda local group are a poster child for this sort of event or a cosmic outlier. Until astronomers know this, their ability to generalize findings from the local group of galaxies to understand galaxy evolution in a broader cosmological context remains hampered. For example, there's a persisting tension between the local galaxy group observations and the world's most sophisticated cosmological computer models, such as the observed placement of dwarf galaxies preferentially in satellite planes around their hosts. And these observations, therefore, suggest that scientists will need to overhaul their current computer simulations. Sweet wants to know the Milky Way will begin its own dance with Andromeda, with the smaller dwarf galaxies rotating around them.
Well, just like in our own local group, that's what you've been describing, our Milky Way, Andromeda, our satellite galaxies, our dwarfs, including the large and small Magellanic Clouds, Sagittarius as well, and dozens of other satellites, we've been studying other systems that are quite like our local group. One in particular is this pair of galaxies, NGC 5713 and NGC 5719. They're quite like our Milky Way and Andromeda in that they're both massive spiral galaxies and they're approaching each other, just like our Milky Way and Andromeda are approaching as well. And they both have associated dwarf galaxies with them. What's unusual about this system is that their dwarf galaxies are rotating around the centre of mass of both of the galaxies rather than being associated with either one. They're not in a random cloud, but they're actually showing this rotation. And what we think is that this system is quite like what our local group will be like in about 2 to 3 billion years.
Some degree of organisation will come together. The gravitational tidal forces won't just simply cause things to plunge through each other. They'll arrange them in a different way.
Yes, that's right. Because as you've described, there's a lot going on just around our Milky Way galaxy. Our dwarfs are interacting. They're also interacting with our Milky Way galaxy, and on a slightly larger scale, we see these dwarfs rotating in a disk around our Milky Way. We also see dwarf galaxies rotating in a disk around Andromeda, and the same thing we see happening around a lot of other galaxies as well. But what we expect is that as our Milky Way and Andromeda continue to approach each other, the dwarfs won't be just orbiting each massive galaxy. They'll actually be orbiting the whole system. And we think this is a way that these flat rotating disks of dwarf satellite galaxies can actually form.
Are globular clusters the cause of merged dwarf galaxies, or are they individual nurseries of stars that have formed together and stayed together?
Yeah, well, there are differences between dwarf galaxies and globular clusters. Globular clusters tend to have slightly, or sometimes much more, simple stellar populations. So they've usually had fewer generations of star formation.
Similar composition,
yes.
And close,
yes.
Very close gravitationally.
Yes, that's right. So we think just a single epoch of star formation in globular clusters. Some are larger, like Omega Cen, you might have heard of, 47 Tuc. These are a bit larger, they're the largest ones, and they have had probably a few generations of star formation and stellar evolution. But dwarf galaxies tend to have a lot more of this, and so even if you're seeing just the cores, you still see a larger spread in their stellar population characteristics. Also, another difference is that when they're the cores of dwarf galaxies, they still have a massive, or intermediate massive, or black hole at the centre, whereas globular clusters don't. And we also have a halo of dark matter still surrounding these stripped dwarf galaxies. There's a few ways that we can distinguish them.
Now, you just mentioned the key phrase, halos of dark matter. These provide what we consider the scaffold of the universe, don't they?
Yes, that's right. We in fact, our simulations trace these building blocks. We have simulations of dark matter halos, and they come together, they gravitationally interact and form larger and larger halos, and so too the galaxies inside them. So in our cosmological simulations, we inject the baryons, or the luminous matter, into these dark matter halos, and we trace the evolution of the galaxies and their halos over cosmic time.
And as you look at these computer models, these simulations, how do they compare with what you see in the real world?
Well, for the most part, very good. They are, our cutting-edge simulations describe a lot about what we see really quite well. One key difference, and something that I'm and my colleagues are interested in, is that it's extremely rare to see a flat rotating disk of satellite around a galaxy. But we see this, as I've mentioned, around our Milky Way, around Andromeda, and half a dozen also other systems nearby to us that we can study in great detail. So it's a bit of a puzzle to know just how this happens when our simulations don't capture it, but they do so well on so many other characteristics. And so that's why what we've found with this rotating system is quite interesting, because we think that's one way that these can form.
As you've carried out your observations and you looked at 5713 and 5719, what are you seeing there? Well,
what we're seeing is that the dwarf galaxies around these two massive spirals are in this sort of like this cosmic dance around these other two. So they've been approaching the centre of mass, but trailing behind their host galaxies. So whereas they might have been isotropically distributed, so randomly around the two massive galaxies as they were more separated, as they're approaching each other, they're trailing along behind. And because the conservation of angular momentum as these two galaxies approach, it's like they're pulling their arms in as like a figure skater spinning faster. And so these dwarf galaxies, as they're approaching too, they feel this gravitational pull, and that's why they're coming in this rotating structure, we think. And so you get these
into line.
They do get into line. It's not a disc shape yet. It's still puffy, and it's like they're in these two wedge shapes, one either side. When you look at an image, you see these two massive galaxies in the middle, and all the galaxies on the left wedge they're approaching us. All the galaxies on the right-hand wedge, they're moving away from us. So it's this really dramatic rotation that we can see.
It sounds like as the merger continues over the next few billion years, these two galaxies won't be forming an elliptical galaxy, but probably a bigger spiral. Am I getting that right?
Yeah, it's possible. It does depend just on the angle of inclination. That's the biggest one. It's a little bit hard to tell from the projected angle that we see, but one we can see edge on, or one we can see face on, and we can actually see in the one that's edge on a little bit of a warp in the disk already. And in fact, the hydrogen gas, the neutral hydrogen that surrounds these galaxies, it's actually already forming a bridge between them. They are already interacting, even though they don't look much like they are in the optical sense already.
Now, when we look at our own Milky Way galaxy, not all that long ago, we discovered a warp in the disk of our galaxy as well.
Yes, and that could be also because, we have this neighbour Andromeda, we are approaching each other, but that interaction is a lot, we've got another, yes, it is, a lot more subtle and a lot earlier on as well. So we've got, like I said, 2 or 3 billion years before we get as close and as interacting as this pair NGC 57, 13 and 19 is. They're a lot more at advanced stage.
Now, when galaxies collide, it sounds spectacular, but it's not like two billiard balls hitting each other on the table, is it?
That's right. There's a lot of empty space between the stars. When our Milky Way and Andromeda merge, the biggest difference for people on Earth, if Earth was still to be around then would be that we would just see the night sky becoming filled with stars. We see Andromeda approaching, but the stars in Andromeda would be moving past the stars in our galaxy, and so we'd see a much more full night sky.
We see those computer simulations of the two galaxies merging. Do you think they're fairly representative, or is your data showing it's going to be a little different to that?
Well, that's one thing that we want to find out. We know a lot about our Milky Way and Andromeda and our dwarf galaxies because they're so close to us. We can resolve individual stars and we study them in such great detail. But we don't know how well we can apply this knowledge to the rest of the universe, in particular because we don't see all of the characteristics in our simulations. So something, maybe like you said, maybe it is just by random chance that we see these planes of satellites, for example. So that's what we're doing with this local group analog study, is looking at these other systems that are as close to our local group as we can find, and looking at them in as much detail as we can, and working out how far down in detail we need to go before we start seeing differences to our Milky Way and Andromeda, and therefore what the limit of that extrapolation might be. This pair of galaxies is one of our sample from our survey delegate, which is so called because the dwarf galaxies are delegates of their environment, so that they represent their host galaxies and their neighbours. We have handpicked these various local group analogues, and this one in particular, my colleague at ANU, Helmut Jurgen, was looking in detail at this existing imaging of this system, and he was looking at the velocity field of the hydrogen between the galaxies, piecing together existing observations that hadn't been combined before, and he had some deep imaging as well, looked at the velocities from existing catalogues of the different dwarf galaxies around the system, and discovered that there was this striking difference between the dwarf galaxies on the left side of the figure and on the right side of the figure, and that's where he got the clue that the dwarf galaxies were actually rotating in this coherent motion around the two massive hosts.
That's Dr. Sarah Sweet from the University of Queensland. And this is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Researchers in the United States believe they may have finally developed the first almost 100% effective prevention drug for HIV/AIDS. America's Food and Drug Administration has now approved the lenacapavir vaccine, which is being sold under the brand name Yeztugo. It belongs to a class of antiretroviral medications known as capsid inhibitors. See, in the HIV type 1 virus, the capsid is the protein shell that houses and protects the viral genetic material, and it's crucial for transporting the virus into a host cell. Once inside the host cell, the capsids shed, and the virus begins copying itself. Lenacapavir stops that from happening. In 2022, it was approved under the brand name Sunlenca to treat HIV in those already infected, but a long-acting prevention medication has been much more difficult to realise. Last year, lenacapavir was named as the Breakthrough Invention of the Year in the journal Science. The drug is now available across the European Union and the United States, and it's awaiting regulatory approval in Australia, Brazil, Canada, South Africa, Switzerland, Argentina, Mexico and Peru. The human immunodeficiency virus HIV attacks the immune system, causing acquired immune deficiency syndrome or AIDS, which allows opportunistic diseases, normally easily combated by the body, to take hold and eventually kill the patient. The World Health Organization says that since first being identified back in 1981, AIDS has killed over 43 million people globally and infected up to 113 million, with 1.3 million new infections annually. HIV is transmitted through body fluids. Right now, there's no cure, although it can be controlled using a combination of complex drug cocktails. Paleoanthropologists have discovered a new species of Australopithecus hominid, the earliest known member of the human family. The new fossil finds, reported in the journal Nature, date back to between 2.6 and 2.8 million years and coexisted with Australopithecus afarensis at the same place in Ethiopia at the same time. The oldest evidence of Australopithecus afarensis dates back some 2.95 million years. The new Leddy-Garou Australopithecus species are based on just 13 teeth discoveries and demonstrate how human evolution was not linear, but a bushy tree with many branches going extinct. The authors are now examining the newly discovered species' tooth enamel to try and find out what they can about what these species were eating. A new study has shown that some seabirds prefer to defecate in the air, so much so they'll actually take flight just to take a dump. Scientists strapped cameras to the bellies of 15 streaked shearwaters, migratory birds that travel from Japan as far as Australia, and they found that all but one of the 195 videoed bombardments were airborne. A report in the journal Current Biology claims in-flight evacuations, for want of a better term, may have benefits outweighing the efforts to take off from the water, like avoiding germs, protecting the bird's delicate bits from seawater, and a comfier position than simply floating. The authors say the findings could also help studies in how seabird excrement contributes to ocean ecosystems and whether bird flu can be transmitted between birds out at sea. Then again, as far as the bird's concerned, it may just be easier to target people from the air. A bunch of academics from the National Autonomous University of Mexico are giving credibility to a UFO report from Colombia. The UFO was first spotted flying over the town of Buga, reportedly zigzagging through the sky in a way that witnesses claim defies the movement of conventional aircraft. The ball-shaped object was allegedly later seen sitting on the ground where it was quickly recovered and taken away for testing. That led to claims there was a strong decaying ionized field coming from the sphere. Others claimed it could be radiating anions. These are negatively charged ions that have gained an electron or another negatively charged subatomic particle in order to fill their outer shells. Those behind the story claim that since the investigation began, this UFO is now 5 times heavier than what it was when it landed. And they say that proves that it's manipulating gravity to make itself lighter in order to fly. Tim Mendham from Australian Skeptic says it's worth pointing out the guy pushing the story has a long history of making elaborate fake space alien claims.
This is a sphere that was supposedly floating in the sky, performing sort of weird movements and things, and then found on the ground, originally seen in Colombia, South America, but there's now researchers in Mexico having a look at it from a place called the National Autonomous University of Mexico. People there promoting some sort of invisible energy emanating from this machine that when it landed, it was a burnt-out area or something. They're saying it sucked all the water out of the grass and the soil, and that there's all sorts of strange things going on emanating from it. There's engravings all the way around it, and the engravings look pretty sloppy, quite frankly, and they do. They're hardly the sort of work of advanced species sending these things across.
How do we know? We wouldn't know what an alien script looks like, would we?
Or would we?
No, we don't, of course. No, there's not a lot of it around. But anything they can't understand naturally becomes alien.
Area 51 anyway.
Yeah, I mean, it was suggested that this is an art project. And in any case, there's no actual link between a thing that was seen in the sky, whatever it was, unidentified, I'm not going to say flying saucer or alien technology, just something that was seen in the sky. And then this was found. There's no necessarily connection, apart from correlation, that these two things are associated with each other. Thing in the sky, ball found on the ground, a bit bigger than a soccer ball, with these strange sort of little carvings
It must
on it.
have been very small people.
I don't know if it was a craft with people inside. There's supposed to be a lot of wires and things inside. I don't know how X-raying this thing or something.
So this advanced civilization is still using copper wires, are they?
This craft apparently bumped up against some power lines, and that took all the energy out of it. So not a particularly good craft for bringing across the great depths of space. But it's just one of those things that you think is just one of those silly things that people are getting carried away with. And there's some academics within this university who are endorsing it. And it's also being heavily promoted by a, quote, UFO researcher who is known for faking and promoting fake products, mummified bodies that turn out not to be sort of mummified alien bodies at all, or all sorts of evidence of UFO sightings that have been seriously debunked. So one of the main proponents of this thing is someone who you really have trouble trusting or certainly believing, and others are some academics who are making some really quite outlandish statements of things that sort of just don't comply with the laws of physics at all, but they're using these as the explanation of why this is a real alien technology. It doesn't look particularly impressive from my point of view, especially the carvings, the engravings on the side of it. They just look sort of amateurish.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.